And welcome to this lecture on lambdas. In this lecture, we'll learn about what lambdas are, how to use them, and some common errors associated with them. Let's jump into the script editor and start. In your viewport, press and hold the spacebar and select Panels, Panel, fifth up from the bottom, Script Editor. You can clear your output window and clear your window at the bottom. And then within History, make sure that you have line numbers in errors ticked on and show stack trace ticked on. So, lambdas. All right, what are they? In Python, a lambda is a function. It's a small one-line function. They are little anonymous functions that can take any number of arguments, but they should really only have one expression. Okay, you can put multiple expressions in them, but they become unreadable very quickly. And the expression is evaluated and returned when the function is called. So very similar and very much like a normal function, like we looked at in the last lecture. Okay, lambda functions are useful when you need to create a simple function on the fly that is only really needs one line. Okay, or when you want to pass a function as an argument to another function. Let's have a little look at how to use them. So here's a nice simple example of a lambda function. Okay, let's say we wanted to square a number. So we're going to go square equals a lambda, give it an argument, so it accepts x, and then we'll do x squared, which is x asterisk asterisk 2. So there we go. Basically, this is the exact same as writing def square, open brackets, x, and then, sorry, there we go. Got to always remember that colon, and return x asterisk asterisk 2, so x squared. This is exactly the same as this. So that's all you've really got to remember with these, is that, okay, this is basically just a smaller way of writing a nice simple function. Let's say you need a functionality within, or just before a loop, you need to define a simple bit of functionality like this. You may not need to write a new function that does something like this, okay? You may just want to write a lambda to give yourself a nice quick little function that can be called within the loop and used. So, let's have a little look. Square. Let's initiate our square functionality. So square equals lambda. And now let's go print square, open brackets 5. So called the same way as functions are. And look, we get 25. Perfect. So we have squared 5 and we get 25. It's simple. You can also just assign this to a variable if you needed to. And again, nice and simple. Highlight and then press Control Enter. And the result, again, Control Enter by selecting the variable will just give us this result of, this is what this equals, 25. So in this example, we defined our lambda function. We've called it square, and that takes a single argument x, which returns its square. We then called the function with the argument x, and we printed the result. Okay, here's another argument that shows you how you can use a lambda function as an argument to a Python map function that we talked about in the map and filter lecture. And this can apply the square function to each element in the list. So if you look back at your notes, or if you remember, within our map and filter lecture, we had our list numbers. We defined our square x, like we just said. Our functionality was square x, and returned our square. Then we had squared numbers, and we mapped, using the square functionality, all of the numbers in the list to the square functionality, and then we printed out a list, essentially, of our items. But okay, let's use the lambda now to minimize our code. Okay, and rewrite this. Got squared numbers, got maps. Now we don't have our square functionality. So what we're going to do is we're going to type lambda. Okay, use x, okay, and then go x, asterisk, asterisk 2, so x squared. And what this should do, let's even just put our list at the beginning again for just readability. And then we can remove list. Just print out squared numbers. So okay, let's just highlight everything, Control All, and then press Control Enter. What do we get? 1 squared is 1, 2 squared is 4, 9, 16, 25. Now, I know what you're thinking, is this more readable? Well, that's kind of what I'm thinking about this, but in your IDE, generally this will be pretty readable. We know that looking at this first item, okay, we're transferring essentially a map into a list. So we don't really need to look at this section. Within our map functionality, again, we know what map does. We essentially are looking at lambda, and then we're going, okay, so we've got a simple little function. So this is what we're doing. We've got the argument before the colon, which is x, so it takes one argument, and then the argument that it's taking, okay, it then runs this functionality of taking the argument x and squaring it. So, and then we've got our numbers list, which is 1, 2, 3, 4, 5. So I'd say it's still pretty readable. And again, for the functionality that it gives, it's given us quite a lot of functionality, quite a powerful set of functionality in here. So let's look at another example using the map and filters lecture and update it with our lambda. So let's have a look at what we did. What did we do? We did numbers, but then we filtered them by what is even, okay, and what isn't. So you'll remember, we use our modulus operator, which is the percent sign. And we said, okay, well, let's divide 2 into x, and is anything that's left over, does that equal, okay, is that equality with 0? Okay, is that using the equality operator? Is that equal to 0? So essentially, if you divide 4 into 2 into 4, everything that's left over is 0. 2 goes in twice, nothing left over, but 2 into 5, okay, you get 2 into it, okay, but you're left with 1, so that does not equal 0. So it's a way of telling, is everything even? All right, so again, what we can do with this is we can steal this bit of code. We can go filter, we can go lambda, give it x, put our colon in. So again, this is our argument, this is what we're passing to it. And then we can go x, modulus operator, 2 divided into it, and then whatever's left over, is that equal to 0 with our numbers. And then we can go, again, let's go list filter. Okay, let's put everything within the even numbers. Okay, variable. And now we can remove that. So what we're left with, again, 3 lines. I'd say it's just about more readable. Again, if you know what you're looking at. We've got list, filter, lambda. So we've got 3 sections. We can quite quickly go, okay, we're transferring to a list. We're filtering. And then we've got our functionality, which here is, yeah, we're dividing 2 into it and we're checking at 0. Okay, it's checking if something is even, which again, if you'd like, you could put a comment above. Okay, just to make sure. And then we've got numbers. So let's print it all. And we've got the only even numbers that are 2 and 4. So I'd say, yeah, it's increasing readability, maybe. But then with a comment, yeah, it's reducing our code. Okay, to look at. It's making it just as easy. Brilliant. So that's a map and filter using the lambda functionality. Lambda functionality or functions can also be used for sorting different lists with customized orders, essentially. So if you wanted to pass a dictionary, a tuple, a list, you could essentially customize the sorting of that data, which we might do in the future in a bit more detail. But let's use a nice simple example to start with. So let's say we've got some words, very complicated concept. So we've got our variable words. Okay, we're typing in apple. Okay, let's go with some different words. Banana, cherry, and date. Okay, so we've got some strings here. Nice little list of strings. And again, we've left a comma at the end. If you had a black formatter running on this, it would say you've got an unneeded comma, and it would remove it for you. Okay, I'd actually remove the white space here, but I'm just using it for readability here. So now let's sort this list in a specific way. So sorted list. is going to equal, let's use our built-in Python functionality of sorted. So again, if we called this sorted, this would run once, but the next time we wouldn't have this built-in functionality because we would have essentially overwritten the built-in Python functionality with sorted until we reopened our Python window, okay, or we restarted Python within the context of our Maya window. So just remember, you make sure you do not overwrite, okay, default Python functionality. So what this does, and normally it takes it in a slightly different order. We pass our words, okay, it's not like map and filter. Pass our words, and then we can use the keyword argument of key, and then pass, and then we're going to say lambda. Okay, we're going to give it x, and we're going to go then with length x. So we're going to say, okay, we're going to sort these by length. So we're actually looking at these, and we're saying, well, okay, what is a length? Because sorted would by default, it would do, it would sort by alphabetically, okay, as we've seen previously in the string section, in the string lecture. But now if we print out sorted, what we should get is date, apple, banana, cherry. Okay, so, well, I'm hoping anyway. So sorted words, what am I doing? So, oh no, what am I completely wrong there? So we've got apple, banana. Let me see, what have I done? Okay, we've got our sorted list. So yeah, we did. I completely was just confused there. I didn't get the output. I must have not hit the right button. Sorted words is not defined. Oh, of course, what have I done? I've done sorted words here, and I've done sorted list here. Of course, that will not make things happy. So there we go. Date, apple, banana, cherry. Again, simple error. Okay, just needed to make sure we're consistent with our naming. In this example, we used our lambda function to as the second argument to the sorted function. The lambda function takes a single argument, x, each string in the list, and then it returns its length. The sorted function uses this information to sort the words in the list, okay, by the length of each string, and returns the new list with the sorted strings. So remember, whatever your information is you're gathering from this, you're essentially going to use that. So in another way, you could even search, or you could order these by, let's say, let's say you wanted to order them by the last letter. Now, I don't know why, but you might want to say -1. Okay, so we use, again, our index point of -1, so the last letter. So remember, we've got 0. And then if we go back, we've got -1, which is the last letter. So, okay, we might want to sort our words by, okay, whatever the last letter is. Okay, we've got A, E, E, Y. Okay, so see, it's worked. Okay, essentially we're giving it what information it needs to search by. Okay, but then if we need to, we can also go reverse equals true. And see, same list, reversed. So really nice functionality. I do love this sorted functionality. It's pretty cool and pretty flexible. So if we passed a dictionary, we would just now have to remember that we would have to look at either keyword, we'd have to look at keys, or okay, or values, essentially. So you can use this with any, again, data type you need to, as long as you're remembering what the data type is and how you need to use it as you cycle through it. Okay, cool. Now let's go ahead and look at some common errors. So these are common errors that I'm sure you'll run into. Again, like I said, I still make errors now. It's not going to be an abnormal thing. It's more so that you kind of get used to spotting where the errors are going to be or what they're going to be, and you get used to knowing what you need to do. So, and if you do make errors, you just get very good at knowing what you needed to do to fix it. So don't worry about if you make a lot of errors. That's kind of what I'm trying to say there. So let's see. Writing overly complex Lambda functions. Like I said at the beginning, these can have multiple expressions within them. They become they can become unreadable very quickly. So just try not to do that. Readability is key. Remember, it's not for you, it's for everyone else. You may find it easy to read that lambda that's got 7 expressions in it, but 1, it's not following coding conventions. And 2, you're going to get everyone hating you that has to work with your code. So avoid nesting too many expressions within your lambda. So I should highlight these when I'm talking about them. So that's writing overly complex lambda functions. Number 2, not assigning a lambda function to a variable. Let's say, unlike named functions, lambdas are anonymous. It means they need to be assigned to a variable to be used. So forgetting to assign a lambda function to a variable can lead to just essentially the not being used. Okay, you'll go through your code and then you'll realize, oh wait, I need to call it, and then you'll say, well, I've done a lambda functionality somewhere, but if you're not assigned it to anything, then again, it's like a function with no name. You can't use it. It's pretty simple. So, number 3, not specifying the default arguments. Like named functions, lambda functions can have default arguments. If you forget to specify default arguments for your lambda functions, you may run into unexpected behaviors. But when calling it with different numbers of arguments mainly. Let's have a look. Not including a doc string. Although lambda functions are typically short and simple, or they should be, including a doc string or a comment above it on what the function does and why it's there, it may be just useful. Again, it's not for you, it's for everyone else. Okay, and that's what I'm going to try and drill into you. Best practices and being a good programmer isn't about you. It's about everyone else, okay? And that's what people will love you or hate working with you. And it pretty much comes down to this, okay? I'm still friends with a lot of amazingly good developers and lovely people. And it's generally because we work well together. But if you like being a maverick and you like doing things your way and you don't want to play by the rules, this is not the life for you. Okay? You can do that. You can work by yourself, but it won't get you far. Working smart doesn't mean being so smart that no one else can understand what you're doing, because, what's the point? You'll only ever have a limit of being able to output so much code in one day. It doesn't matter how good you are. You need a team behind you to help you do anything truly great. Like I've talked about before, I'm an Elon Musk fanboy. He's amazing. But he couldn't do everything he does if he didn't organize and put the systems in place to make everyone work well together. And that is what we're going to be focusing on, not just you, but the systems that make you great with everyone else. And that's what you've really got to think about. Elon Musk didn't make Tesla. He had the ideas for it, but he employed amazing people, which aren't commented or aren't talked about enough, to do that. Okay, you've got amazing people to work on the drivetrain, okay, the design, the production line, the really specialist people that work on all these things, and they all work together and they document what they're doing. Now, if they didn't work together, and Elon Musk couldn't do all that stuff. It's common sense. Okay, he's a great man, but he's only good because he employs very good people to work with. So that's just a little bit again. Sorry, digress a little bit and go off on a tangent sometimes, especially when I'm tired. Long day. Okay, as I've said, I write these after work, so very sorry about that. But hopefully you'll glean some information and useful information, always even more importantly, from what I'm saying. So, not following Python style guide. So like I've said, PEP 8 is what we generally follow, okay, within Python, which we're going to go into more detail in PEP 8 and best practices, the lecture, just a few on from this, maybe in another 4 or 5 lectures. It's important to follow PEP 8, which is, again, it's our coding conventions when writing Lambda functions, as you would for any other of your Python code. Just because they are cool little cute functions, it doesn't mean that they'll be useful if you don't write doc strings for them, if you don't have a useful variable name, if you don't use the white space effectively, if you've got about 10 of them bunched up together with confusing names like X, Y, Z or ABC, and those are the variable names within a function, the next person coming to read it is going to be like, well, what the hell do all these 4 functions do? Okay, I want to look through these functions and just say, or just know exactly what they do by having one called squared, one called filter by, and what it does, and then one by one saying another. But they're just saying useful names, okay? Format your code consistently and make it readable. So in this video, we've learned about lambdas, okay? They're very cool little things. You'll use them a lot. Okay, we've learned about some of the basic ways of how to use them and some common errors that can be associated with them. But thank you so much for listening, and I look forward to seeing you on our next video.